today we discussed about the new chapter, that is molding procedure and types of molding processes. Okay, see here that molding. So how the molding process will be taking place? So what are the steps to be taken before starting the molding process? So I see here we have a few points is there in order to develop that things. Okay, so first one is the molding process. So how it starts. Okay, mold. So take the molding box. So it consisting of a cope and as well as drag. Okay, and so that cope and drag will be kept on the molding board. Okay, so first we can take the molding board and over it. So you can take the cope and others you can take the drag. Okay, so the pattern is kept inside the molding box. Okay, on molding board. Okay, first you can take the pattern. Okay, so before that we prepare the pattern. So that pattern will be we keep on the molding box. Okay, so the parting sand is dusted on the parting pattern surface. So see here the parting sand is there. So there is a red powder or we can call it a brick powder. So that will be sprinkled over the pattern surfaces. Why these pattern surface is required to dusted means, see, in order it does not sticks to the pattern to the sand. Okay, see, if we are not dusted the parting sand to the pattern, so the pattern surface will be sticked to the sand. Okay, so to avoid that thing, so what to do, just we can sprinkle the or we can dust the parting sand. Okay, and then next the facing sand is poured up to a depth of 25 mm. So you can take the molding box. Okay, that is called. So over which you can place the pattern and you can dust the parting sand. After that we can take the facing sand, that is facing sand will mix it properly. So that facing sand with the help of shower, because the facing sand will be filled the molding box. So cannot fill completely, so only a part of depth. Okay, so that is up to 25 mm. So the depth of 25 mm we can fill it. Okay, then after that, after filling of surface so box, okay, then we use baking sand. Okay, so baking sand is filled. Okay, so after placing sand we can go for the baking sand. Okay, so then then after that we can go for the ramming. Okay, we can take the rammer. So by using the rammer we can what we can call ramming you can take place. Okay, the corners also we can go into ramming. So due to the additions and coincidence, so what happens, so the sand particles are stick to each other and become stronger. Okay, so that's why we can go for the ramming option. So after completing the backing sand filling of comments, so we use the excess sand. Okay, so excess sand is cut off with the help of striking bar. Okay, so the backing sand is completely filled with the molding board. So after that, so some sort of sand will be excess. Okay, that excess sand can be removed or cut off by using a strike off bar. Say here we have in the figure we have various stages. Okay, so you can see here. The first we can take the molding board. So and then you can take the drag box. Okay, so in the drag box you can fill the you can place the pattern. Okay, so that is a stage 1, that is a figure A, and figure B, say after placing the pattern, so you can use the parting dust. Okay, sand dust. So parting sand will be sprinkled on the pattern. Okay, then afterwards you can use both. Okay, water facing sand and as well as backing sand. By using both, so completely we can fill the box. So if it is any excess sand is there, that can be cut off by using a strike off bar. So for you can cut it, then you can see them. So the drag is turned over. Okay, so after that, so whatever the drag is there, the drag is turned over. So then cope is placed on the drag. So after completing the process, turning out, then you can use a cope box. Okay, so the parting sand is sprinkled over the pattern. Okay, so if the pattern is turned, so the upside pattern is there, so over there, so you can sprinkle the parting sand, and then you can place the screw and as well as riser, that simply called as runner, and riser is placed in a position. Okay, so the molding sand is filled in the cope. Okay, molding sand also you can completely you can fill it. Okay, so after filling you can go for the ramming operation. Okay, so by using a rammer you can go for the ramming. So at corner also you can going to fill it. Okay, so the excess sand is removed by using a strike of bar. Okay, then after completing of this operation, the what are the screw and the risers are placed in a position that will be withdrawn slowly. Okay, so that is withdrawn slowly. Then the cope is lifted off. Okay, slowly the cope is lifted up and set aside. Okay, you can keep aside. Okay, so that what happens, so now the both, so before that what happens, so the drag and as well as cope is keep one over the other. Now the cope will be separated, the two things will be separated right now. Then now you can withdrawn the pattern. Okay, the pattern is withdrawn from the drag. Okay, so from the drag the pattern is withdrawn. Okay, so that is, so finally the cope and drag is clamped put together. Okay, finally, so slowly what happens in both cope and as well as drag, in both molding fast, so the pattern is there. So from both you slowly you can remove the patterns. Okay, then the metal the metal is melted and separately in electrical furnace or electric furnace. Okay, so normal furnace or electrical furnace. So here whatever duty is that, so that metal, whatever the metal is there, that metal will be melted. So if you melt it, then that is called so that melted metal, so that is called molten metal, we can call it a molten metal. Okay, so that molten metal will be poured into the mold cavity. Okay, so here after removing the pattern from the mold, then that becomes as a mold cavity. Okay, so in that mold cavity, say after both things you can remove, then once again the cope will be placed on the track. Okay, now from the top surface you can pour the molten metal into the mold cavity. Okay, so here when the molten metal is cooled down, okay, the mold is broken. Okay, so this process is called solidification. Solidification is nothing but it's a process of cooling from molten metal to a solid state. Okay, so that's the process is called solidification. Okay, so now after that the casting is separated. The casting is separated. So this operation is called molding. Okay, so this is called molding procedure. So in a figure you can able to see very clearly. So in pattern A is figure A, B, C, D and E. So in figure A the pattern, sorry, you can take the drag box, so that will be placed on the molding board. So after placing the drag box you can place the pattern. So after placing the pattern you can simply you can touch the parting sand. So the parting sand is used to separate the both the operations. Okay, so separate the sand and as well as the pattern. So that is the property of the parting sand. So then afterwards you can take the facing sand, so you fill the up to 25 mm. Then afterwards you can fill the backing sand completely, you can fill it. So the excess sand is there, that excess sand will be cut off by using the strike off bar. Okay, then after that you can till the drag. Okay, so then it will becomes till in part B. So part B and part C, so figure C, so the pattern is tilted. Okay, so the molding box is tilted and the pattern will become upside. Okay, so over there we can once again we can use the parting sand to sprinkle over the pattern and you can use the pattern. So if it is a two-piece pattern, once again the second of the part is placed over the pattern. And now the screw pin and riser. Okay, so simply it is called as runner and as well as riser will be placed in a position near to the pattern. Okay, then we can place the cope box. Okay, so then we use the backing sand to completely you can fill the pattern. Okay, so after filling, then you can take the rammer. So with the help of rammer, so you can, so what we can call after ramming, so you can use a rammer. Okay, so after completing the rammer, so slowly what happens, the screw pin and as well as riser pin, these two pins are uh, withdrawn from the mold. Okay, so slowly it will be withdrawn from the mold. Okay. So after that what happens, so after withdrawn slowly, then the core box is separated from the both, so that will be keep aside. Okay, so from the both, so from cope and as well as dog, so what happens, you can use to withdraw on the patterns. Okay, if the pattern is available on the cope, so if it is single piece pattern, so only the drag will be kept. Suppose if it is a multi piece, that is a two-piece pattern, so the in cope and as well as drag in both things, so the pattern is there. Okay, from both the two it will be removed. Okay, so that is called pattern. Okay, so after removing the patterns, so slowly, so once again will be keep one over the other, that is cope and drag will be merged together. Then from the screw pin, so okay, from the screw pin, so the molten metal is poured. Okay, so the molten metal, how it is by using electrical furnace or the furnace, so in that the metal is melted. Okay, so the melted metal will be taken in the ladle, or you can call it the crucible. From the crucible you can pour from the screw pin. Okay, so from the screw pin, from the screw pin to the pattern, so that is called mold cavity. So there is a entrance. Okay, entrance is there, that entrance we can call as a gating system. Okay, after removing the screw pin and razor pin, we used to cut the gates. Okay, so the gate cutting system is there, so you can use the cut the gate. The gating is nothing but so it is a passage of molten metal entering into the mold cavity. Okay, so after that the molten metal poured from the screw pin, so that will be directly enters into the mold cavity. So if it is excess after completing the mold filling of your mold cavity, so that molten metal will be raised through the riser pin. Okay, so from screw pin you can pour it, from the riser pin you can able to observe it. So that will become over, it is excess flow. Okay, overflow, so that what happens we can understand that, so the mold will be completely filled. Okay, mold cavity is completely filled, then you can use to stop pouring. Okay, after completing of this process, the metal will be allowed for solidification. Okay, so the molten metal is there, so the molten metal is cooled, okay, to solid state. This process is called solidification. Okay, so the solidification will be is there, it takes the time. So after completing of the solidification, the solid it becomes solid, then used to break the mold. Okay, used to break the mold. So from the mold you can use to take the casting object. Okay, so used to take the casting object. So after casting you can send for the inspection, or you can go for the machining operation to bring the exact sizes. Okay, and as accuracy. Okay, this process is called molding process. Okay, so it is very simple. So then classifications of molding process. Say here we have the various classifications are there. So according to the method used. Okay, so according to the method used. So the first one is bench molding, second one is floor molding, third one is pit molding, and fourth one is machine molding. Okay, so here four molding processes are there: bench molding, floor molding, pit molding, and as well as machine molding. Okay? So bench molding is done on bench. Okay, so the flasks are kept on bench. Okay, so the molding is done on bench. The flasks are kept on bench. So convenient height of the bench is selected. So it is employed for the small castings. Okay, so it is employed for the small castings. So that is called bench molding. And then next to floor mold. Okay. So the molding is done on floor, foundry floor. The molding is done on foundry floor. It is used for medium to large casting. It is used for medium to large size castings. Okay. And then pit molding. Okay, so pit molding means molding is performed in pit. Okay, so molding is performed in pit. Okay, so pit is dug on foundry floor. Okay, pit is dug on foundry floor. It acts as a mold or drag. It acts as a mold or drag. Okay, so here in general we can take the cope and as well as drag. But in pit molding, so only we can use the cope. So the drag is not necessary. So the drag is act as a pit. Okay, drag is act as a pit. Okay, a separate cope may be used. A separate cope may be used. So it is adapted for the large castings. So it is adapted for large castings. Okay, so no need to lift again and again. Okay, so then next one is machine molding. Okay? So it is employs for mass production and batch production. It is employs for mass production and as well as batch production. Okay, so it enables higher accuracy. It is enables higher accuracy, enables higher output. Okay, so various operations are performed by machine like ramming or removal of pattern and gate cutting. Okay, this can be done by the machine itself. Okay, so the various operations are performed by the machines. Okay, machine itself it will be performed. So ramming can be done proper ram. Suppose if you do the excess ramming, so what happens? The mold cavity may goes to crack. Okay, so removal of pattern. By removing the pattern also, you can use very carefully. You can take the ramming, or otherwise it may be chance to shape out the mold cavity. If it is once the mold cavity is shaped out, so automatically the size may get the variation. Gate cutting also, so you can cut the gate cutting very accurately. So if you are not cut accurately, so the molten metal poured from the screw pin that will not be enters into the mold cavity. So that is a problem. Okay, so these all operations are performed by the machine. It will be done exactly. Okay, so that is about the machine molding. Okay, according to the, so this molding is done according to the method used. According to the method used. Now classification according to the molding materials. Okay, so here we can done with the help of molding materials. So what are the molding materials? It is a green sand molding, dry sand molding, and skin dried sand molding, loam molding, cement bonded molding, ceramic molding, and as well as shell molding. Okay, so these are the various types of molding materials. Okay, so green sand molding. Okay, so in this molding, moist sand and with the clay is used. Okay, so moist sand and clay is used. It is used for small and medium sized castings. It is used for small and medium sized castings. So drying of the mold is not necessary. Drying of the mold is not necessary. So while doing the molding process, the mold may wet, that is called moist. Okay, so after completing a molding process, immediately go for the casting operation. No need to dry the green sand mold. Okay, so molten metal is poured immediately after completing of molding process. The molten metal is melted in the furnace, so that melted metal will be poured directly into the mold cavity. Okay, so here the name indicates green refers to the moisture, not the color of sand. Green refers to the moisture, not the color of sand. Okay, so it is not the color of sand. So what are the advantages means? So it is the least expensive, so consumes less time, so flask can be reused. Okay, flask can be reused. Okay, less distortion problems and less dangers of hot tears. So these are the advantages we have. Okay, least expensive, consume less time, a flask can be reused, less distortion problems, less danger of hot tear. Okay, so what are the disadvantages means? So sand control is critical. So moisture is in sand may cause defects. Okay, so if it is a grain, okay, a grain contains moisture. Okay, so if while the mold is in moist state, so at the state itself we can pour the molten metal, so it may cause some defects. Okay, it may become the blowholes or something other thing. So the surface finish is poor. Why? Because it is a wet state, so the surface we cannot put a very smooth surface. So molds lacks the strength. Okay, so strength is weak. Okay, these are the advantages and disadvantages of green sand. So green is not a color of sand, it is a moisture content present in it. Okay, so what are the applications we use means? A ferrous and non-ferrous alloys can be casted. Ferrous and non-ferrous alloys can be casted. Used for small and medium casting. Used for small and medium sized castings. Okay, that is about the green sand. And next one is a dry sand. Synthetic sand is mixed with the binder and water. Synthetic sand is mixed with the binder and water. A synthetic sand does not contain clay. Synthetic sand does not contain clay. So mold prepared is baked in oven at 240 degrees temperature. Okay, so the mold is baked. So dry is nothing but there is no moisture content in the mold. Okay, so it is mixed with binders and as well as water. Okay, so synthetic sand does not contain clay and okay. So mold becomes stronger. Why? Because it is in wet states. So dry state it becomes stronger. Okay, used for medium to large casting. Used for medium to large castings. Metals like cast iron and mild steels are casted. Metals like cast iron and mild steels are casted. So what are the advantages? See here we have the few advantages are there. Stronger than green sand mold. So defects are avoided. Defects are avoided due to baking. Defects are avoided due to baking and better surface finish. Better surface finish. Stronger than green sand mold. Defects are avoided due to baking and better surface finish. Okay, so these are the advantages. And coming to the disadvantages, so the cost of production is high. The cost of production is high. Slow production rate. Slow production rate. So mold distortion. So mold distortion. Susceptible to hot tear. Susceptible to hot tear. Not suitable for light and intricate casting. So these are the disadvantages. Means the cost of production is almost all high compared to green sand. So it takes us slow production. That means so it takes a time consuming process. Why? Because so after preparing of molds, the mold is in wet state. So from wet to dry, it will take the time. Okay, so that is the problem. Next is skin dry sand molding. Okay, a synthetic sand with a bentonite binder and water is used. Okay, synthetic sand with bentonite binder and water is used. Okay? So the surface of mold is dried up to a depth of 15 mm. Okay, so skin dried. Okay, only up to a part of depth only we can dry it. Okay, remaining is as usual. Okay, so drying is done by carbon dioxide or hot air. Drying is done by carbon dioxide or hot air. Adapted for ferrous and non-ferrous alloys of large size castings. Okay, so large size castings. Okay, this is a skin dried. So only up to a part of depth. So we can go for the drying process. So the drying can be done by the carbon dioxide or hot air. Okay, so it is adapted for ferrous and non-ferrous alloys. Okay, so after immediate drying, so you can go for the molding, pouring the molten metal. Okay, so what are the advantages? It's a less expensive. Okay, we are not going to be dry completely, so there is a less expensive. It requires less time. Okay, carbon dioxide is hot air, so it will take a speedy time. Okay, so stronger than green sand mold. So it is stronger than green sand mold. So what are the disadvantages? It is more expensive. So it is a weaker than dry sand mold. Why? Because it is not completely dried. Only the partially it will be dried. Okay, so that is the reason why. So it is a weaker than dry sand mold. Okay, and loam sand mold. The next type of molding sand is loam sand mold. So the mold made with loam sand. So mold made with loam sand. So sweep pattern is used to prepare the mold. Sweep pattern is used to prepare the mold. So it is rotated in loam sand. It is rotated in loam sand to make mold. Rotated in loam sand to make the mold. So mold is dried to provide the strength. Mold is dried to provide the strength. Used for large castings of symmetrical shapes. So it is a large size castings. Where the large size castings are there we use this application. Okay, large cylindrical paper mill rolls are casted. Large cylindrical paper mill rolls are casted. Okay, so this is about the loam sand figure. So only the pattern is there, the pattern will be seeped out. Okay, so the sweep pattern, what happens over the pattern, the sand will be swept so that it will be dried, then the mold is made. So advantages are large castings can be casted cheaply. So symmetrical castings are made. Okay, so disadvantage, it is a slow process and laborious. It is a slow process and laborious. So and skilled molders are required. Skilled molders are required. So these are the loam process, loam sand molding. So here we have the various types. Okay, according to the materials used, according to the method used. So like this, we'll see. So in tomorrow class, in next class, we can see the remaining molding sands and special casting sands. Okay.